Welcome back to AI Elemented Tweet. Today, we're switching gears and delving into a crucial topic, the detection of cadmium. This toxic heavy metal poses threats to both our environment and health. Join us as we embark on a visual guide to explore the methods of identification, starting with scenarios you might encounter in your everyday life. Cadmium, a silent intruder in our lives. It's not confined to controlled environments, it's in the air we breathe, the water we drink, and even the food we consume. Let's unveil the visual story of how cadmium infiltrates our daily existence and how we can detect its presence. Imagine this scenario. You're enjoying a cozy evening, and you light a candle. Did you know that the flame's color might hold clues about cadmium? It's not just a lab experiment, it's a potential revelation in your everyday surroundings. When heated in a flame, and reacted with hydrogen sulfide gas, cadmium produces a characteristic yellow color. The formation of this yellow coloration is indicative of the presence of cadmium ions. Now, let's talk about water, a source of life. Cadmium salts exhibit specific solubility characteristics. For instance, cadmium carbonate is sparingly soluble in water but dissolves in acids. Observing the solubility behavior of a substance in various reagents can help in identifying cadmium. For a quick, on-the-go detection method, picture using paper strips. These strips, infused with selective reagents, change color in the presence of cadmium. An easy visual indicator for a quick assessment. Think about it. These detection methods can be applied in real-life scenarios, from industrial settings to everyday materials we encounter. Taking it up a notch, we delve into quantitative tests using sophisticated instruments. Envision scientists in a lab setting, utilizing tools like atomic absorption spectroscopy and inductively coupled plasma mass spectrometry for precise measurements, ensuring accuracy in cadmium detection. Atomic absorption spectroscopy relies on the principle of light absorption by free atoms. Imagine a sample being vaporized in a flame or heated graphite furnace. The magic happens when atoms absorb light at specific wavelengths, and for cadmium, it's like tuning into its electronic transitions. As the sample dances in the flame, the absorbed light is proportional to the concentration of cadmium. Our trusty detector quantifies the intensity of the transmitted light, creating a spectrum. The absorbance at this characteristic wavelength becomes our key to calculating the concentration of cadmium. AAS is not just highly sensitive and specific, making it perfect for trace metal analysis, but it's also a straightforward technique to operate. Now, let's amp it up with inductively coupled plasma mass spectrometry, for short ICP-MS. ICP-MS, the powerhouse of multi-elemental analysis. Here, inductively coupled plasma, a high-temperature plasma, is generated by ionizing a sample with a radiofrequency coil. Picture a swirling sea of ions and electrons. As the sample enters this plasma realm, it's ionized, and then the magic begins. The ions are separated based on their mass-to-charge ratio using a mass spectrometer. Cadmium ions step forward, identified by their unique mass spectrum. ICP-MS doesn't stop there. It offers high sensitivity, a wide dynamic range, and the ability to analyze multiple elements simultaneously. This makes it a versatile maestro, particularly in complex sample matrices and detecting cadmium at trace levels. Colorimetry, another powerful technique, involves visualizing colored complexes formed with specific reagents. The intensity of these colors directly correlates with cadmium concentration, offering a visually striking way to quantify its presence. As we conclude our visual guide on detecting cadmium, let's reflect on the importance of these methods in safeguarding our environment. Stay informed, stay vigilant, because cadmium detection matters. Thank you for watching. Stay tuned as we continue to explore cadmium.